In the previous lesson, we talked about singly linked list. While deleting the last node in a singly linked list, we had to keep track of two pointers, the last pointer and the second last pointer. Also, we could only traverse in a single direction. These are some of the major disadvantages of the singly linked list, and in this chapter, we will learn how to address these problems using doubly linked lists. The doubly linked list is called a two-way linked list. It's because each node has two pointers, one pointing to the next node and another pointing to the previous node. The main advantage of a doubly linked list is that it can traverse in both directions, but due to an extra attribute, each node of a doubly linked list occupies some extra space. The node of a doubly linked list holds the data, next pointer, and previous pointer. This is how we can find the node class more formally. Implicitly, the next and previous pointer of a new node points to null. You can also implement str method to print the data of the node. Like singly linked lists, there are three basic operations in a doubly linked list. You can traverse the doubly linked list, which means you can sequentially explore the items of the list. You can also insert and delete items. This is the class definition of the doubly linked list. Now let's look at how we can implement some of these operations. The first case is to insert a node at the front. First, we update the next pointer of the new node to current head and previous pointer of the new node as null. Then we update head node's previous pointer to point to the new node and make the new node as head. Here is the implementation part. In the first four lines of the code, we take care of the case where the list is empty. For that, we just need to initialize a new node with data and update the head. If the list is not empty, we proceed in the same way as a singly linked list. One major difference is that we have to update the previous pointer of the current head before we update the head to point to the new node. The next case we are going to look at is inserting a node at the end. Recall that in a singly linked list, we traverse to the end of the list and insert the new node. We proceed in the same way in a doubly linked list. Like before, in the first part of the implementation, we take care of the case where the list is empty. Then we traverse the node till the end and update the next pointer of the tel node. Additionally, we also need to update the previous pointer of the new node to point to the current tel. We can also insert a new node somewhere in the middle. We'll leave that as an exercise for you. If you have any difficulty, the code snippet is available in the reading section. So now, let's shift our discussion towards deleting a node from a doubly linked list. In programming languages like C, we use a temp pointer to hold and delete the temporary node. And like we learned in the previous lesson, Python implicitly takes care of this. So here's how we delete the node. At first, we check if the list is empty. We can't delete a node from an empty list, so we throw an error message. We might only have a single node in the list, in which case we update the head to point to none. If the list is not empty, we simply update the head to point to its successive node and update the previous pointer of the new head to point to null. We can proceed in a similar way to delete the last node, but as we said at the start of this lecture, that the major advantage of the doubly linked list comes during deletion. So let's understand this in a bit more detail. Recall in a singly linked list, to delete the last node, we traverse the list till the end, keeping track of the previous pointer. This was done because we didn't have a way to traverse back. In a doubly linked list, we don't have to do that because we can simply use the previous pointer to access the second last node. Let's look at the implementation. The two conditional if statements take care of the case where the list is empty and the case where we only have a single node in the list. If we have only a single node in the list, we update the head to point to none. Else, we traverse the list till the end and use the previous pointer to access the second last element. Then we update the next pointer of the second last element to point to none. And that's what the last line of the code does. So that's it for the doubly linked list.